right. Thank you, Esam, for that introduction. Hello, everybody. It's a pleasure for me to be here with all of you. This is the first webinar of what hopefully could become a webinar series on a broad range of topics, depending obviously on your own feedback. Okay, now I do not have a presentation, a PowerPoint slide pack to talk over. Instead, what I want to do today is to show you live, in a live demonstration, how you can leverage Excel and a bit of Visual Basic to build your own applications, right? And I want to use the Z compressibility factor as an example. So as you see on this animated GIF on the screen, we want to create a little app where the user can enter the specific gravity, temperature, and pressure, and this app will calculate the Z factor, right? This is the end product after today's session. This is one we want to arrive at, okay? And we're going to do that using Excel and Visual Basic. So let's kick things off, and let me just open an Excel application. So we're gonna do it from scratch, and it went to my other window. So let me just drag it to the share window. So this is the Excel file that I just created, and the first thing we're gonna do is to save this as, let me just drag this thing over. The first thing we're going to do is we're going to save this as a macro enable. I'm going to save it on my desktop for now. And what you need to be doing is save as macro enable workbook. That's the first thing that people sometimes forget, and the macros are not enabled. We're going to be running Visual Basic code, therefore we need to enable macros. So we're going to save as a macro enable workbook, okay? And we're going to just call this test, or whatever name you want to give to the app, okay? Now, again, the example that I want to use today is to calculate the Z compressibility factor. So we're going to use the Hall-Yarborough correlation. And I want to bring this Whitson website, which you may be familiar with, is, and drag it to the screen. So you have this Whitson wiki website. Curtis Whitson is basically the PVT guru. And this amazing website here, you can go to the right-hand side and click on that Hall-Yarborough estimation. And this will tell you exactly the methodology to calculate the Z factor. So as it says at the top, is an iterative approach using the pseudo-reduced properties of the gas. So we're going to take this website to extract all the formulas we need to implement in our Excel file the calculation that we want to do. So let me just put this side by side, and let's start building in Excel the calculations that we need. So let me just make some room there so we have the formulas on the right hand side as we build the calculations on the left hand side. Okay, now we're gonna need the specific gravity of the gas. Let me just put here gas specific gravity. Okay, and I'm gonna put in yellow cell whatever is going to be a user input. So let's say 0.6, which is a typical gas gravity value. Then we want to enter the pressure and temperature. Okay, and again, I'm gonna highlight this in yellow because these are user inputs. And let's say we want to use, as an example, 5,000 psi, and temperature we're going to use 200 degrees Fahrenheit. Okay, now we're going to start calculating things. Now the first thing we need to do is to turn the temperature into degrees Rankine, because we need an absolute temperature measure to use in formulas. And as you know, this formula is going to be the temperature plus 459.67 to turn that into degrees Rankine. And we're going to use the blue color to refer to whatever is a formula or a calculation, not a user input. Okay, so the first step we need to do is to calculate the pseudo-critical properties, which are taken from the methodology in Curtis-Whitson. So this is from here on, it's just following all the formulas that are indicated in the methodology described here on this website. So we need the critical temperatures. We're going to use here, it says the Saturn correlation is what yields better results. So we want to bring those two formulas to here. So those two are going to be yellow cells because they're going to be calculations and not user entries. And one little neat trick that I'm not sure that everyone is aware of, that these variables or cells in Excel, you can actually give names to them. So the references in formulas become more intuitive and easy to track. So for example, here, you see that refers to the cell C3. You can just click here and rename that thing. I'm going to rename it gamma because gamma is the Greek letter used to refer to the specific gravity. Same here, you see on the pressure cell, that is cell C5, but you can C5 there, you can just click on it and rename this thing. So we're gonna rename it as pressure. Likewise, the temperature, we're going to rename it as temperature. And the one we want to use in formulas is the absolute. So make sure you click on that one, this degrees ranking. So that's gonna be temperature. Okay, so once we have that, we can actually start typing cells and calling for those references using the names themselves rather than absolute cell coordinates. For example, this one here is going to be like that. Just for the sake of time, I'm pasting from other Excel where I already have the formulas to save time, but you can see the formula there. 756.8 minus 131 gamma, you see on the Curtis-Whitson website, that's the formula where I have my pointer. That's the one that I have here on this cell. You can see it uses the gamma value, which refers to the cell where I have the specific gravity. So that's why it's so useful to have the cells named in Excel. So that's going to be the pseudo-critical temperature. Likewise, for the pseudo-critical temperature, we're going to use the formula, which you see on the website, and I'm going to paste it there. You see the formula 169.2 plus 349.5 gamma minus 74 times gamma square. So we use those formulas, and there you go. So what we need to be doing is to keep going down all of these formulas in the Whitson Wiki website to build all the calculations we need to finally arrive at the Z value. Now, for the sake of time, let me just drag this file out which we just created, and let me bring the one that I already created with all the formulas needed, just for the sake of saving time. So I don't want to spend time typing too many things here, but you can see, you just continue going down, and all of these are formulas that appear on this methodology described on the website. So pseudo-reduced pressure, so where is it? Is at the very top. Pseudo-reduced pressure is pressure over pseudo-critical pressure, which we just calculated. So that's pressure over PPC. Temperature is temperature over TPC, which are the ones we just calculated before. Then we have this alpha parameter, which is that one there. You see the formula? That formula is exactly the formula you see here, which uses a theta parameter, which is that one there, and theta is 1 over TPR, 1 over TPR. So what I'm showing you here is two things. One is we just follow the methodology described on this website, calculating all the parameters we need using the formulas explained here, and we also are using names to make it easy on us to audit the formulas we have in each cell. This is a neat trick to always be accustomed to using. It's very useful. Okay, so after we define a few defining parameters, we enter into this iteration, which is the process that is described here. So you start by assigning a raw value. That's the methodology that is described here. So you guess the reduced density parameter raw. So you start with a value, okay? And then you calculate these parameters F1, F2, and F3. Again, all I've done for the sake of saving time, I've already put those formulas here. So F1, you see there, F1 is minus alpha times PPR plus rho, rho square, rho 3, so on and so forth. I've done the same for F2, F2 14.76, F3 90.7. You see, these formulas is just these formulas expressed in the Excel worksheet. So after we calculate F1, F2, and F3, we're going to calculate next the derivatives of F1, F2, and F3 using the formulas that are described on the website again. And at the end, we end up with a process in which you need to iterate on the value of this row. That's the methodology. That's how you end up at the right value. This is Newton-Raphson optimization routine. So the way this works is you need to guess row until the calculation of f is 0. Now in this case, it had already been initialized with a near 0. So let me just change the values just for the sake of the example. Let me just change the pressure to 5,000. Let's leave the temperature at 200, or let's put 250 Fahrenheit just to test things. Now everything changed, so we need to recalculate rho, and rho needs to be calculated by iterating. Now how do we iterate in Excel? So a new value of rho will trigger all these calculations. And what we need to do is to estimate rho such that that tends to 0. You see that there? So that's the iterative process. Now to iterate in Excel, we can use the Goal Seek function. And the Goal Seek function is under data, what if Goal Seek. Now you can bring this Goal Seek, if you use it very frequently, you can bring it to your ribbon and have it readily available for you. But for now, let's just use it in this way. So what we want to do is to set cell, and the set cell is going to be the absolute value of f, and we want that to be very small. So let's say that for now. You can go even smaller than that, and I'll show you in VBA in a minute. But for now, let's do that. And the cell we're going to change is going to be this one. Okay, so just OK, and this thing is going to start iterating. Okay, already found a value. That was a quick iteration, and the value it found was that one, and with that value, f tends to 0. You see that's very small. That's fine. And now finally, after doing that calculation, we can come back and we have everything we need for our Z factor. So Z factor is calculated as alpha times pseudo-reduced pressure, PPR, over rho, pseudo-reduced density. Okay, so don't get too overwhelmed with the formulas. All I've done here is to follow the Hall-Yarborough methodology described on this Whitson website. So all I've done is created formulas following this to calculate the Z factor. Okay, so this is what you would typically do if you wanted to calculate Z factor using Excel, nothing else. Right? Now, this is obviously not very convenient because every time you change any of the parameters, let's say you change the pressure or the temperature or the gas gravity, and you need to go here and reiterate. Now, this is a little bit annoying, right? And especially because you cannot translate this into other workbooks where you may also want to calculate the Z factor. Z factor obviously is a key parameter to derive the expansion factor or the BG factor to compute your in-place volumes. So therefore, it's very useful to have a way to readily calculate the Z factor in Excel. Okay, so the next step is we're going to recalculate Z now using Excel VBA. I don't know how many of you are familiar or very familiar or not a little bit familiar with Excel VBA, but I'm going to start, just recording a macro. So one way to call VBA is to just go onto the developer menu at the top and you just call for VBA there. Okay, and that's going to bring this blank canvas. We have nothing created on VBA yet. And by the way, let me just close the other Excel file I have created before at the beginning, test, not to have two on the VBA interface. So this is the Excel file we're working, and instead of going straight to VBA, I'm going to record a macro in Excel itself. So the way to do that is you go here again, developer, and you go record macro. And what this will do is it will turn into VBA code anything you do on the Excel. So let's just record anything, right? So let me just say, I'm going to name that macro test macro. Okay, that's it. And now it's recording. So everything that I do will be translated into code. So I'm just going to do something really simple. I'm going to enter a number 2 there, and on the cell right next to it, I'm going to enter a formula, and it's going to be that times 2. Very simple stuff. And I'm going to stop recording. That's all I did, right? I entered a 2 in that cell, and then I entered a formula which multiplies that cell by 2. Now, I stop recording. Now I want to see the code that was recorded. So you go onto the macros option there, and it tells you you have just one macro, the test macro that I just created, and you go edit. And that will bring, again, the VBA interface here. And you will see that the test macro was recorded. Those means those are comments. You can delete them. This is the piece of code that was created when we did that. We entered a 2 there. In that format, you can see if you haven't been in VBA ever, you can immediately notice that this is fairly intuitive to understand, right? So this is the code that we recorded where we entered a number 2 in that cell, range G3. In G3, we enter number 2. And then in cell H3, we enter a formula which calls the preceding cell and then multiplies by 2. Now, let's say you want to edit the code. You can see here how intuitive this is. Instead of a number 2, let's enter number 10. And instead of multiplying by 2, let's multiply by 10. So if I run this code now with that play button, this is updated with a 10, and the formula is times 10. It calls the preceding cell times 10. So see how easily we created a piece of VBA code by recording macro in Excel. This is the best way to learn code, by the way. Just record yourself doing anything in Excel, and then you try to figure out what is it that the code is trying to tell you. Now, let me tell you another intuitive thing here. Remember that I told you you can name cells. So instead of referring to the cell G3 as G3, you can refer to that cell using the name. So let's say, for the sake of this silly example, let's say I want to use a year in which I was born, 1977, and here I'm going to calculate my age, and it's going to be current year, 23, minus that. So that's my age, right? So let me delete that, and I'm going to name this cell year, and I'm going to name this cell age, just for the sake of the example that I want to show you. So instead of referring to that cell, actually I'm going to delete the whole thing for you to see how intuitive this is. So I want to refer to the cell year, so instead of using G3, just use the name, range year. And the beauty of this is then you can move this around and it's going to retain that name. So instead of selecting the cell, I'm just going to enter directly a value. 19, let's say it's 1950. And I'm going to run that. Okay, but before running, let me enter the calculation in the next cell, which is age. Remember, we named that age there. And the calculation is going to be 2023 minus range year. As an example, you see how intuitive this immediately is? So let me run this now. And there you go. So it was 50 and 23 minus, and that's the number that ended up in the cell. So immediately you created a macro that you can run, and you can start populating your cells. The beauty of this, I was saying, is you can just move these things around, and the cells will drag the name across. Okay? So you don't have to worry about what was the column or the row number. You just refer to the name. Now, another thing useful for you to know, this is another Excel little neat trick. You can run quickly, let's say a code. Let's run a for cycle from 1 to 10, and then you do next I. And I want to do is range. Let's use the same cell that I already named year, okay? and I'm going to enter there the number I, where I is going to loop from 1 to 10. So what do you think this thing is going to do when I hit play? It's going to, let me just add there, offset I, comma 0. What does this mean? It tells you, go to the range year, that's the name of the cell that I want to start, and then go offset. Offset means move that, which is going to be a cycle number of rows, and that number of columns. So stand 0 offset in terms of columns, so therefore stay in the same column, and then offset each time of the cycle I number of rows as you move down. So let's run that so you understand what it does. So it moved in each part of the cycle, it offset one row down, but no columns, 0 column offset, and then write in the cell the number of the variable I, which changes as you loop through the cycle. So what I want to do now is to actually repeat the calculation of the set factor, but instead of doing it on Excel itself, I want to do it via code. Okay? Now, again, I'm just going to be using the formulas as expressed in that Whitson website. So if I bring the website again, and what I want to do now is to write a piece of code within VBA. And the first thing that I want to do is to calculate the pseudo-critical pressure using that formula there. 756.8 minus 131 times gamma. Gamma is the variable that I'm now passing as parameter of that function, and times minus 3.6 times gamma square, right? So I've done a very simple piece of code where all I've done is I brought to the VBA the very same formula that I used here, pseudo pressure. That's the very same formula, but I'm writing that formula inside VBA. Now, the beauty of this thing is now this is a public function. What that means is now you have an available function for you to use anywhere in Excel or anywhere in any other workbook. So you can call this function as you would with any other function. So let's say you go insert function, and then you select here user defined functions, and that function is available for you to use like any other Excel function, right? So select that, that's the name of the function, PSC, and you hit OK. Now it's going to ask for that one parameter that it needs, which is the gamma or specific gravity that is used within the formula. And now, because it's an Excel function now, you can actually do not need to enter a number, you can actually refer to a cell. So I'm going to click on that cell, and it's going to bring that cell into the formula, and there you go. I have calculated now via a VBA function the pseudo-critical pressure. Now I can do the same with any other one. So let's bring now the formula for TSC, sorry, the pseudo-critical temperature. That's the formula that you see on the Whitson website, 169.2, 349.74. That's the formula. It's exactly the same formula that I had used before here. That's the formula, right? Now I'm creating a public function using VBA. Okay, so now, same as before, I'm going to call a user-defined function. Now it's the temperature, and that is going to again ask for the specific gravity. So you can call that cell with specific gravity and OK. So you see it's the same number. Now I've calculated it using a user-defined function. Now the beauty of this, as I said before, is now you have an Excel function available to use anywhere in Excel, even in other workbooks. So let me open a new Excel workbook for you to see what I mean. So in here, if I have another blank workbook and you need to calculate stuff, you can actually find this formula here as well. So you go insert function and you go user defined, and now it tells you, but it tells you that it comes from a different workbook, but still available. So PSC, the gamma, you can now refer to a value in this workbook. You don't need to go to the other workbook. Let's say the gamma is there. I didn't enter it, so it's going to throw So 0.5. You see it updates. It refers to that cell is calling that gamma or GG. This is the one that I use in the formula, and it updates. Okay, so very handy to build public functions. So you have the ability to call on those functions anywhere in Excel in any workbook. Okay, so let's continue now, and let's bring now the public function for the set compressibility factor. Okay, that's it. So I brought the entire formula. You need to trust me that I brought the exact same formulas that are in the website that we've already implemented in Excel. These are the formulas that we have, and this is where the iteration happens inside of the code. So we don't need to invoke Goal Seek or do any iteration in Excel itself. All of that happens inside of the code. So you can explore this in your own time, but the idea is exactly the same. You start with a value, you calculate the f's and the derivatives, and then this asks within the code, is that low enough? If yes, exit. If no, go and iterate, changing that value by a different, by splitting that with the Newton-Raphson methodology. Okay, so this is typical methodology to iterate on that optimization little routine there. And once we have that, we have the function we need to calculate the set factor. So we go to set, as I did before, PC and TC, and we got the same numbers. Now let's go here and let's calculate the set factor invoking that set function. And that's gonna need the pressure. So the pressure is going to be that value, the temperature is going to be that value, and the specific gravity is going to be that value. And okay, boom, there we go. That's the set factor calculated with our set function rather than iterating within Excel. Okay, great. So what's next? What we want to do next is to turn this into a friendly user interface. But before doing that, let me just briefly, I know we're running out of time already, but one thing that is very handy, obviously, when you have this as a function, and you can imagine yourself having a list of pressure values. Let's say, let's create a list of pressure values all the way from 5,000 to 500. And here I'm going to calculate the set factor, and I can use the formula that we just created. Okay, so that is going to be calling for pressure. And instead of calling the one that I have there, I'm going to call that cell. Temperature is going to be that one. I'm going to absolute it with the F4 keyword. So as I move down, that doesn't change. And the specific gravity, again, is going to be gamma. That doesn't change because it retains the name. Okay, so that's the set factor. And if you copy that down, you can see there is calling that gamma and that temperature and that pressure. Okay, gamma, temperature, and pressure. Okay, so very quickly, we created ourselves already a set function, and we can chart this and see how the set varies with pressure very quickly using the formula we just created that leverages the Hall-Yarborough correlation. Now, the next bit is let's turn this into a visually appealing interface. So the first thing we want to do is to go back to the VBA interface, and now what we want to do, so let me close that workbook, book 3 we created, just to delete that from there. So this is very clean now. And let's go back to Visual Basic. That's our workbook. And what we want to do now is to create a form. Okay, so we're going to go there, insert, and go user form. You have this toolbox here, and you have this property panel here. So the first thing we want to do is you click on the element and you want to give that a name. So let's say that's called a PVT. How can that's the name of our form element. Okay, so you need to give it a name that is going to mean something that is logical to you when you first look at it. So FRM for form, and then let's say this is a gas PVT. And the caption is what actually shows on the form itself. So the caption user form 1 is what shows there. So this is the internal name of the element. This is what you want that to display. So let's say PVT calculator or whatever, right? And we know we need three elements. We need a gamma, so that's going to be caption of that element label 1, gas specific gravity, enter, that's it. And now we're going to create another one for the temperature. So just click on that and just drag on this form element. So we're going to label that as pressure. Okay, enter, that's pressure. And again, click on the element toolbox, that text element, and this is going to be temperature, temperature, enter. That's it. Okay, and you can drag this around to make it more visually appealing, so you can play around with this in your own time. So for now, let's do just that. And then what we want to do is to enter a text box. So we're going to call this text box. So txt for text, gg for gamma. Then we're going to create another one. So remember that text box, we're going to drag that there. I'm going to name that txt. This is going to be pressure. Enter. And then again, we're going to text box there. And this is going to be txt for text element and temperature. Okay. That's it. So we have the three inputs. And now here we want to have the calculations. That's going to be a command button. Okay. And this is what's going to run the calculation. So the caption is going to be z equals, and here's where we want to drop the value of the calculation itself. Okay, so we bring again the text box and we're going to name that text txt and set, because that's the value we want to bring. So what we do next is when you double click on any of these elements, it brings a piece of underlying code that is going to run when you hit that element. Okay, so what we want to do here is to now allocate values to those elements we just created in the form. So let me just, for the sake of time, copy this that I already had created before. Let me make it more understandable to you. Okay, so that's the sub, or the subroutine, or the procedure that's going to be run when we hit that command button. Remember, that's the command. When we hit that, it's going to run that code, and that code is going to actually, remember the naming we use in Excel. So the range gamma, that's that cell there, that cell is range gamma, is going to be allocated the value, which is the txt_gg element. So that's how we name that element. Remember, txt_gg. So what we're saying here is that cell is going to acquire that value, which is the value of that element there. And same with the other ones. Pressure, range C6, sorry, is that one, is going to take the temperature value, and range pressure, which is that cell, is going to take that value. And then the other way around, we're going to bring to the form element the value from the sheet now, and the sheet is going to be range zcalc, which is the one we're calculating here. So we need to name that zcalc, and that is the value that is going to be brought to the form element. So if we run this form now, let's have a look if this works. So we run the form, and it's going to bring this form here, and we're going to enter value. So let's say 0.6. Pressure is going to be, let's say, 4,000, and temperature, let's say, is 150. If we hit Z, it's and the end of sub end function. Yeah, so that's a problem in the code. I forgot to delete that line. So let's run this form again. And specific gravity point, let's say 0.5 for the sake of the example. 4,500, 50, and Z. And Z is bringing 0.98. So this is what happens. In the sheet, we enter 0.5 and 4500 and 150, and it was brought back to the form the value from the sheet. So if I close that and check that those were the numbers there, that's exactly 0.5, 4500, and 150. Let's do it again. Let me drag this to the top so we see everything next to each other. So those are the values that I'm playing around in the form, right? That's it. So let me just highlight that just very briefly with that, just so you understand side to side. When I run the form, I'm going to run the form again. So here I am, run the form. And what I want to do now, specific gravity is going to be 0.65. Pressure is going to be 2500, and temperature is going to be 250. Let's run Z. There we go. So 65 was brought to the sheet from the form, 2500 from the form, temperature 250 from the form, and now Z was calculated here by the function we created, and the resulting value was brought to the form. So if you are the user, this is all you see, right? Now, I don't think I will have time to go through the entire process of creating the entire application, but let me just see if I can manage in the remaining 7 minutes very briefly. So the way to do this is now I'm going to create a little routine that at the end here in the modules where we create the code, I'm going to create a little run form routine that is going to open that form PBT every time we run that hit. So for example, if I run that routine now with the play, it's going to bring the form. Okay, it did run the form. This is the same as running the form there, but now doing it from within a routine. And you also can do is to bring that little piece of code to this workbook page here. So that means whenever I open this file, open the form immediately. This is what that instruction means. So just to test that, let me just close this and save it. Okay, save it, and now I'm gonna bring where I have saved that file. So I'm going to open it, and immediately as I open that file, it's going to trigger that form. So the form is going to open immediately. So I'm nearly there. I'm nearly where I want it to be. All I need to do now is to hide the Excel altogether. All I want for the user is to see the form. And the way to do that is with a little routine, which you can create as a Visual Basic script. This is the code. You define a variable myApp, which is going to refer to the Excel application, and I'm going to give the instruction to not be visible. You do that by making that visible property false. Okay, so I'm saying do not show it when you run Excel. That's what I'm saying. And in here, you just bring the path to the Excel file you just created. Okay, and then a little bit of an instruction to not warn you when you close the files. And then when you save this, you just give Visual Basic script extension. So script 2, you just explicitly specify Visual Basic script. That's it. And that'll turn that notepad file into a script. You see the icon? That's a script icon. And then you can double click on it and run it. And all I was telling you just now is you drag that to your desktop, okay? Or as a shortcut to your desktop. So you can right click on it and go to properties, and in properties you can change the icon to something, anything. You can bring your own icon, right? So there you have, an icon on your desktop, and that icon is going to run the script, and that script is going to open the form, it's going to hide the Excel application, and you're gonna end up with this. Okay, so there you go, an Excel based application for you to calculate anything you want. I did it with the set compressibility factor as an example. Obviously, you can actually extrapolate from here and build anything you want using Excel, especially because all of you are already very used to working with Excel databases anyway. So it only makes sense that you have the capability of creating applications within Excel without having to go to third-party software all of the time.